This is the second part of the Chapter 8 review video. In number 5, we are graphing logarithmic functions, which remember are the inverse of any exponential function. We're basically going to start out by again graphing the parent function, which is log base 4 of x, which would have the common points 1, 0, 4, 1, and 1/4, -1. And therefore, the -2 out in front will multiply these y's by -2. So therefore, sketching a graph of this, I'd have the point 1, 0. I'd have 4, -2. And I'd have 1/4, +2. Which would be approximately right there. Now, as in our other graphs, x plus 1 is going to move it left 1, minus 3 is going to move it down 1. So each of these points I'm going to move left 1 and down 3, left 1, down 3, left 1, down 3, left 1, down 3, and this graph is going to get closer and closer to -1 without touching. So your domain would be x is greater than -1. Your range, since it's the inverse of exponential, logarithmic ranges will be all reals. Changing forms, if I have a log form and I'm changing to exponential, I have the base. So my base here is 3. The log equals 4, and the log is an exponent, so the exponent has to be 4. So it would be 3 to the 4th is 81. Another way to look at this is to begin with the base, go counterclockwise. If you do that, it'd be 3 to the -3 is 1/27. If it's exponential, changing the log form, obviously we're going to write down the word log. The base here is 3, and it should equal 5, because 5 is the exponent. And then we can just fit in the 243. Checking this, 3 to the 5th is 243. Write down log, my base is c. It should equal the exponent, which is b, so therefore this would be d. C to the b is equal to d. Evaluating these expressions mentally, this is a base of 2. This means 2 to the what power is 1/16. And mentally, 2 to the 4th is 16, but since it's 1/, it'd be -4. This would mean 9 to the what power is 27. To do this one, we would need to get the same base. I could write 9 as 3 squared, 27 is 3 cubed, and then the 2x must equal 3, so x would be 3/2. Next type of problem is solving logarithmic equations. If you've got a single log as we do in A, we're going to just change the form of this. 2 to the 5th is equal to 7x minus 20. 2 to the 5th is 32. I'm going to add 20, divide by 7, so x would be 52/7. Number 9b, we have multiple logs, but they're the same base. They're equal, so therefore x squared minus 15 must equal 2x. This is a quadratic equation, so I must get it to equal 0. I'm going to subtract 2x. It's a quadratic that I will factor. And my solutions would be positive 5 and negative 3. Checking these, again, we need to make sure we're not taking the log of a negative number. If I put 5 in there, this would be 10 right here, and this would be 10, so that's okay. If I put negative 3 into this, that would be 9 minus 15, which is negative. That can't be true. So 5 would be your only solution. 9c means that x to the 2/3 power is 4. To solve this, you take both sides to the 3/2 power. By power of power, these would cancel. 4 to the 3/2 is square root of 4 cubed. So it's 2 cubed, which is 8. So I hope these two videos help you in preparing for Chapter 8 if you still need to take that summative or you would like to retake it at some point.